In this video, I'm going to explain the problems how to solve for the especially lathe topic. Now, first we'll see the problem. A hollow workpiece of 75 mm outside diameter and 180 mm length is held on a mandrel between centers and turned all over in 4 passes. If the approach length 18 mm, over travel 10 mm, average speed 0.9 mm per revolution, and cutting speed is equal to 28 per minute, calculate the machining time. So already in my earlier video, I told for all the problematics, first you had to note down what is the data is given in the problem. Then you had to identify what you are going to determine. Then start the solution. Now let us see the first, the given data. So outside diameter, the D is given 73 mm. 73 mm is given. And the second, length between centers. The centers means here live center and dead center, that is given 180 mm. And number of passes required to finish the component, that is mentioned here 4 passes. Then approach length. Before start cutting the workpiece, the tool is set a distance away from the workpiece. That travel, that length is known as approach length, that is given here 18 mm. Next, the overall travel length. The over travel length, that is after finishing the component, the tool slightly go behind that length of the component, that is the 10 mm. So the average feed is given 0.9 mm per revolution, and the cutting speed V is equal to 28 meters per minute. And what you are going to find out, that is the total machining time required to complete the component with the required dimensions, that you need to find out. Now let us start the solution. So the cutting speed, we know the formula, the cutting speed V is equal to pi dn by 1000, where V is the speed and D is the diameter and N is the speed. Now the cutting speed V is mentioned 28 and pi, D is given 73 mm, and here we are going to find out this N value. So that the spindle speed N is obtained 122 RPM. So once if you know the spindle speed, then you can find out the machining time. Now let us calculate the machining time for one pass, single pass. That formula is L by F into N. L is the total length traveled by the machine tool divided by feed into the spindle speed. Now I can find out the total length traveled by the tool L is equal to, so the LC plus LA plus LO. So that length of approach plus length of overturn plus length of machining. So now we can find out, substitute this data, that 180, 18 and 10, then it's overall it's obtained 208 mm. 208 mm. So the machining time for one pass, the TM is equal to, machining time for one pass, TM is equal to L by F into N. That L is 208 divided by 0.9 is the feed and 122 is the spindle speed. So now I can obtain this 1.89 minutes. That is the machining time for one pass. Now how many passes are given? 4 passes. So the total machining time TM is equal to the time taken for one pass into the number of passes required, that 4, that is equal to 1.89 into 4. So that is 7.577 minutes. Okay. So the total machining time required to complete the component is 7.577 minutes. So this is the problem. I hope you understand this problem, how we can solve. Now let us see the next problem. A hole of 30 mm diameter and 75 mm depth is to be drilled. The suggested feed is 1.3 mm per revolution and cutting speed is 62 meters per minute. Assuming the tool approach and tool over travel as 6 mm, calculate the spindle RPM, cutting time and material removal rate. So the given data, the hole diameter is given, that is D is equal to 30 mm. D is equal to 30 mm. Then the depth to be drilled, that is given 75 mm. The 75 mm is given. And the tool approach length that is mentioned, tool approach and tool over travel is mentioned, that is 6 mm. So you can take separately 6 mm and 6 mm. Then what is the data is feed is given, that is mm for revolution 1.3 and cutting speed V is equal to 62 meters per minute. Now you can find out what spindle RPM N you are going to determine, and the cutting time that T is equal to you can determine. The material removal rate M is equal to going to determine. These are the things we are going to find out from this problem. Now let us see the solution. The this earlier problem I have seen the cutting speed. That cutting speed V is equal to pi d n by 1000. Use this formula, you can find out the cutting speed. So now we can find out this n value. N is obtained 657.84 rpm. Next, the machining time for one pass, that is L by F into N. Now, the total length traveled by the tool is obtained. This is LC plus LA plus LO. Then the total length traveled by the tool is equal to 75 plus 6 plus 6, that 87 mm. So the machining time that is obtained, the machining time is equal to 87 by, the feed is 1.3 divided by the 657.84. So from this, the machining time is obtained 0.1 minute. And the metal removal rate, M is equal to obtained diameter, feed and speed. So the M is equal to 30 into 1.3 into 6,000, 62,000. So the divided by 60 you can obtain the metal removal rate in terms of mm per second. So that is a 40,300 mm cube for the second. That is the metal removal rate M. I hope this problem you know how we can calculate the spindle speed and removal rate we have see. I hope everyone understand this problem.